Hi everybody, Captain Al speaking. Welcome to Training Tips designed to help make you a better, more knowledgeable flight simmer, pilot, or aviation enthusiast. Let's strap in and stow the HUD and see what is on the horizon for today. Our briefing today will cover the Electronic Flight Instrument System Control Panel, otherwise known as the EFIS Control Panel. Let's get started. Each pilot has an EFIS control panel, one for the captain, one for the first officer. The EFIS control panel controls information that's displayed on the PFD, the primary flight display, and the ND, the navigation display. The EFIS control panel consists of a panel that has rotary controls, toggle switches, and push button switches. Going from left to right and up to down. From the left you have a minimum selector that allows us to set either radio altitude for minimums or barometric altitude for minimums. Typically on a Cat 1 approach or a non-precision approach we would set baro minimums. On a Category 2 approach or Category 3 approach we would set radio minimums. There is an outer and inner selector that allows for the setting of either radio or baro, and also to set the actual minimums themselves. Moving to the right of that, you have the flight path vector switch. When you turn this on or off, it displays the flight path vector on the PFD. Next to that is the meter switch on the altitude portion of the PFD. When you push meters on, it displays meters as well as feet. If you turn it off, then meters will disappear and you'll be left just with feet. This would be used in areas of the world where you have to use meters, such as China. Just to the right of that is the baro switch, which is used to set altimeter in either inches or hectopascals. Again, there's an outer rotary switch and there's an inner rotary switch. The outer is used to select either inches or hectopascals, and then the inner is used to set the actual altimeter setting in inches or in hectopascals. Moving down, you have a little toggle switch that's used for left VOR and left ADF, or to turn the display off. Moving to the right of that, you have the ND map select switches here, or mode select switches that encompass the approach mode, VOR mode, map mode, and plan mode on the navigation display. Just to the right of that is the range selector, which varies from 5 miles to 640 miles. And then just to the right of that would be the switch for the right VOR or right ADF, or to turn that display off on the ND. At the bottom there are EFIS map switches. Each of these switches controls information that's displayed on the ND. You can display weather radar returns, or display VOR nav aids, or waypoints that are in the database, airports that are in the range on the ND, various data information that shows up at waypoints when you push the data switch. Position would display your GPS and IRS position along with some raw data radials, and then terrain would display terrain on the ND. There are some inner switches associated with the rotary switches. These are little push button switches that are associated with either resetting minimums when you reach minimums through the RST switch on the inner portion of the minimum switch. The STD, or standard little push button switch, is for the baro. When we get to our transition altitude, we would normally go to 2992 inches. When we push standard, that's automatically displayed by displaying STD on our PFD. And then the center push button on the ND mode switch is used to go from expanded mode to full 360-degree compass rose by pushing center. The traffic switch is used to display TCAS traffic on the ND when the switch is pushed. Alternately, you can turn on or off the traffic by pushing the switch again. Let's take a look at the virtual simulator. And we'll be looking specifically at the EFIS Control Panel, which is highlighted in white. You'll notice that we're out of 10,000 feet. We're climbing to our cruise altitude of 38,000 feet, or flight level 380. We're out of 250 knots now, accelerating to our econ climb speed of 329 knots. We're going to look at setting the baro and radio minimums. The outer selector, which is located right here, is used to go back and forth between baro and radio. We're on baro right now. The inner selector, which is being turned, is setting our minimums. We're going to set 1,210 feet. For the minimums, you'll notice when you slow down, we get single-digit increments. If you go fast, they're in increments of 10. The faster you go, the more the numbers will spin. The faster they'll spin. So we've got minimums of 1210. Now if you rotate it counterclockwise, you can see the knob moving. We can get rid of the baro minimums on our PFD. If we go all the way to minus 101. Minus 100 it shows up, but minus 101 it will disappear. Taking the outer selector and moving it to the radio position will allow us to set the radar altimeter. Or the radio minimums. In this case, we're going to set the radio minimums to 200 feet, indicating 200 foot above touchdown. And again, normally the only time we normally set this would be for Cat 2 or 3 approaches. Some airlines will set this with their baro minimums even on a Cat 1 approach, but that's per airline procedure. If you spin the selector counterclockwise, you'll get rid of the radio display when it goes negative. Let's take a look at the baro in inches of mercury or hectopascals. We just switched over to hectopascals, in which case you'll get the HPA indication or the inches indication as we see here. The inner selector is used to increase the altimeter setting or decrease the altimeter setting as necessary. Counterclockwise will decrease and clockwise will increase the altimeter setting. And the outer selector is used to select inches or hectopascals. The inner switch is used to select the actual altimeter setting. Depending on which part of the world you're in will depend on whether you use hectopascals or inches. Typically in the United States we use inches. And you can see here we are setting hectopascals with the switch in HPA. Transition altitude in the USA is 18,000 feet. We're approaching that now. So once we get through our transition altitude, we'll transition to 2992 inches. And that'll give us a standard pressure altitude above 18,000 feet. Of course, we don't have to set 2992 inches. All we have to do is push the little inner push button switch, which says STD. And when you do that, it will change to standard, and that is 2992. Let's take a look at the VOR ADF switches. They're located at the bottom left and bottom right. With both switches off, nothing is displayed. When you turn both switches on, then you'll see VOR information that is displayed on the NavRad page. You'll get the identifier. In this case, for the right VOR, it's Seattle, and the DME is 35.1 miles. ADF would be blue, as you see here. The EFIS Control Panel also allows us to go between expanded mode and the full 360 compass rose by pushing the center switch. When you push center, you get the full compass rose. In this case, we're in the 80-mile range. This is 20, top is 40, behind us is 20, and all the way to the bottom of the scale would be 40. So 40 miles on either side. The total range is 80 miles in this case when you're in the full 360 mode, as we are now. If you push the selector back again, it would go back to expanded mode. We are in the map mode right now, and we'll switch to the plan mode and take a look at that briefly. As we go to the plan mode, the orientation of the airplane changes from the way we were actually heading to a true north indication. So it's exactly how you'd be looking at it if you were looking at a chart. And for planning purposes only, this allows us to see our route of flight as it would be represented if we were looking at a map. In this case, you can see we are heading east-northeast. The airplane position is denoted by the airplane. And in this case, the bluet is in the center of the plan display. Let's take a look at the VOR mode. If we go to VOR, that will select the VOR mode. And depending on what you have on the NavRad page will depend if you see anything here or not. You can see in this case we have our left switch to ADF left. We have the right switch to VOR right. We are showing the big fat needle, which is the number 2 or the right VOR. It's a fatter needle. The left VOR would be a skinnier needle. You can see we've put something in on the NavRad page now. We've manually tuned, in this case, Ellensburg, ELN, on the NavRad page. We put a course in, and that's the only way you can get a course displayed. You'll get the to from indication, the course deviation bar, and a representation of what it would take to fly to that particular course. Let's take a look at the traffic switch on the EFIS Control Panel on the range selector. This allows us to set our TCAS traffic to turn it on and off. You'll notice that shows up in the lower left corner here. When you turn it on, it says TFC, and when you turn it off, it goes blank. If we turn our weather switch on, we're going to get weather radar information displayed on our ND. If you turn the station switch on, you're going to get stations displayed on the FD. You'll see here the weather radar in the turbulence mode is on. Stations are also displayed now that we have the station switch on. Anything above 80-mile range is going to be high altitude nav aids. Anything in the 10, 20, and 40-mile range is going to be a low and high altitude nav aids. So really from 80 miles on up, it's strictly high altitude nav aids you're looking at. Let's take a look at the waypoint switch. If you turn the waypoint switch on, you'll get the waypoints that are displayed in the database for your selected range. You'll only see waypoints in the 10, 20, and 40-mile range. You can see here we are in the 20-mile range, now we're in the 10-mile range, and we see waypoints. As soon as you go above 40 miles, the waypoints disappear. You can see that it can get rather cluttered with a lot of waypoints, so they're inhibited from 80 miles on up. The airport switch will show the airports in the database. Typically, these are airports that are optionable. The airline will choose which airports they want. For most airlines, it'll be a hard surface runway with greater than 6,000 feet in length. You can see as we bring the range up now, you can see all these airports in Canada. Here they are in the U.S. down here, and Canadian airports up here as we expand out the range to 320 miles. The data switch allows data to be displayed for each waypoint. It'll have the time at the waypoint, and if there's any altitude restrictions at the waypoints, that'll be listed. You can see the times are all listed on each waypoint, even down track waypoints. And again, altitude restrictions will also be listed on those waypoints with the data switch pushed. Again, it shows up over here whether data is pushed or not. When you turn the position switch on, you're going to get position information on the ND. If we go down to the lowest range, 5 miles, you'll see we have the GPS symbol. And hard to see, but their little star symbols would be the 3 IRSs. They're probably pretty much bunched together, especially in the higher range. You also get raw data information to the VORs that are on the NAVRAD page. And you'll get some green radial lines along with raw data information. You can see here that Wenatchee, we're just, you can barely see it here, but EAT, we're just about passing over that VOR now. And you should see this needle start to swing as we pass over the VOR and go behind us. And so anytime you have the position switch on, you have the GPS symbol, you have the 3 IRS symbols, a little hard to see, but they're there. And you'll have these raw data radial lines going to both your VORs that are being tuned on the NAVRAD page. If we had the NAVRAD page up, you would see that. And lastly, we're going to look at the terrain switch. By pushing the terrain switch on, you will display terrain that's in the database and shown on the ND. You get a little better view of it here. You can see the star symbols there that are the IRS positions. They're all bunched up, all 3 of them together is one. Now we've got the terrain display on. We've reached up here, we push terrain. Again, you'll see that right here. We still have the airport switch on here. We have terrain on here. And we have our TFC, which means the traffic is being displayed on the ND as well. The terrain is displayed in colors of green, amber, and red. Anything green is usually 500 feet or more below the aircraft. And you can see in this case the highest terrain in this area of the ND that we're looking at is 2,900 feet and the lowest area is 500 feet. And of course we're well above that at flight level 340 and continuing our climb to flight level 380 in VNAV as we climb. Typically if the terrain's amber, it'll be anywhere from 500 feet below to 2,000 feet above. And if the terrain is red, it would normally be above 2,000 feet. The meter switch and the flight path vector switch will be covered in the PFD altitude and the PFD attitude sections that we will go over that. Okay, that completes our discussion of the EFIS Control Panel. Best way to learn it is to manipulate it, fool around with it, and see what it displays. Let's lower the HUD and go flying. Till our next briefing, keep the blue side up. Captain Al, out.